Solving quadratic equations by the square root property. Square root property. Let k be a non-negative constant, then x squared is equal to k. It's equivalent to x equals plus or minus the square root of k. And we have some examples to follow. So in this case, example A, we have x squared equals 18. In this case, we're trying to solve for x. So let's get rid of the square. What's the opposite of a square? Remember those trees. What do trees have underneath the ground? Roots. So square root on both sides then. We will, similar to adding and subtracting, to get rid of addition and subtraction. Do the opposite. So opposite of square, square root. And we got to do it to both sides of the equal sign. There it is. So square root and the square are equal and opposites. They cancel each other out. Notice I did not cancel the x. So let's take a look. What is the square root of 18? What number times itself gives you 18? This is where your calculator could come in handy. Because otherwise you're going to be guessing and checking for a while. The closest thing we can guess was maybe 4 times 4 is 16, right? Or 5 times 5 is 25. So somewhere between 4 and 5. Well, let's try with a calculator. Calculator. And go ahead and turn it on. And let's take the square root of 18. If you press the second square root button, if you press this x squared button towards the middle of your calculator there on the left side, you have a square root sign there. So that brings it up. When you push second and the x squared gives you the square root. So square root of 18, close your parentheses and hit enter. It gives you 4.24 roughly. Keep in mind your calculator only gives you the positive value. So x equals 4.24 roughly, and let's remember we need a plus or minus to that because it could be both positive or negative. And there's our answer in this case. Alright, so let's try b then in that case. X squared minus 28. So it looks like in this case we just added one extra step to a problem similar to the one before. So in this case we got to get rid of the 8 first. So it's subtraction. Let's add 28 to both sides of the equal sign. Similar to problems you've done in the past more than likely. The only difference is the x squared now. So we have x squared equals positive 28. Now we get rid of the square via the opposite, square roots. Remember those trees. Alright, so the square root of a number squared, or x squared, cancel each other out because they're equal and opposite. The x is left by itself. Square root of 28, once again calculator time, because the closest thing we can get is 5 times 5 is 25, right? And 6 times 6, 36 goes over our value. So in this case, let's see, second square root button, or the x squared, to give you the square root button, 28, close your parentheses, hit enter. 5.29 would be our rough value. So there it is. And once again, let's remember your calculator only gives you positive values, so we need plus or minus added to it. So there is our final answer in this case. Let's check our solution. And last but not least, C. We have in parentheses x plus 2 squared, and that equals 49. So in this case, notice that we can't get rid of the 2 from the inside of the parentheses. We can't do anything with the x inside the parentheses. We cannot distribute the exponent of 2 because it's addition. We can go the lengthy route and expand this to say in the set of parentheses x plus 2 times another set of parentheses x plus 2, but you're going the difficult direction. Be aware of that. In this case, it's somewhat more straightforward, just solving for x by getting rid of the square root. So we get rid of the square root from both sides. Once again, cancel the square root and the square on the left side. And that leaves us with x plus 2 equals 7. 7 times 7, 49, right? Oops, let me not forget the plus or minus. There we go. And now to get rid of the 2, so subtraction, opposite of addition. What we do to one side, we must do to the other. And let's realize, in this case, we get 2 possible answers, right? Because of the plus or minus. So it means we get positive 7 minus 2 and negative 7 minus 2. So 7 minus 2 gives us positive 5. And negative 7 minus 2 gives us negative 9. So there are our answers. Alright. Looks like we're finished, but we can actually do a secondary check here, just for reference, especially since we have our calculators handy. So let's use our calculators to make it a little bit more handy. So in our calculators, I'm going to go to the graphs, I'm going to go to the y equals, and let's take a look at the first example, x squared. So if I push x, and there's a square button once again on the left side, the one that you use to make the square, but we are not using the second feature, just the square. So press the x squared, and it squares your x. Or you could also likewise do a caret key chew. So both of them will technically work. You can either do the square or the caret key and then the chew. It implies the same for your calculator, squared. If you have TI-84, it automatically raises it for you. Be aware of that. And on the y chew, we're going to say equals 18, or it's 18. So we're going to go to zoom, and I'll start with zoom standard, option 6. Middle top button is your zoom, and option 6 for zoom standard. It looks like this. We can't see where they intersect. So we're going to go to zoom and go to zoom out, option number 3, push number 3. And it doesn't zoom out. That's because you have to hit enter. Hit enter. There we go. And now we can actually see where they intersect each other. So go to zoom, and I'm going to try the zoom box. Option 1, hit enter. I'll move the cursor so you can see where it's at. There's my cursor. I'll hit, well, maybe I should move a little further to the left. There we go. I want to encapsulate that first crossing point. I'll hit enter once. Push up, 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 up until you're past that intersection point. Go to the right and you'll begin to see the box finally being built. There we go. I'll hit enter. That way it encapsulates both of my intersections. There it is. And in this case, we already have a rough value example. So if I hit trace, trace is right next to graph on the very top right. Second to the right. So hit trace. That allows you to enter any x value. So I'm going to plug in 4.24. And that should give me, hey, look at that, something pretty close to 18, 17.9776. If I enter negative, because remember it's a positive or negative, so negative 4.24, same value but negative, it should give me the other side, which is also pretty close to 18. Once again, the symmetrical point. All right, look at that. And now let's try the next one. Go to y equals once again, clear both of those. And we're going to try the next equation, which we have here on the left side, our examples. So we have x squared. Once again, you can push the square button or the caret key and then put a true. Minus 28. And the equals 0, we don't need to put anything. And I put on y2, but it's okay. It still works. You can put it on y1 and that'll be fine. I'll go to my zoom and do zoom standard, option 6. And there it is. I can actually see where they intersect. So I won't zoom in or zoom out. But you can tell it's a parabola that's partially cut off the top and the bottom. So hit trace. And let's enter 5.29, 5.29. And hit enter. You'll notice you get a value close to 0. That's because you got equals 0 on the V example, example V. Let's try negative 5.29, 5.29 with a negative. Remember, your negative, you want to use your negative sign at the very bottom, the one next to the enter, not the subtraction sign. So now hit enter, and it gives you the opposite one, the one on the left now, which is sort of close to 0 because we rounded our enter. Let's clear it out, and go to y equals and clear that one out as well. So in y1, I'm going to enter a set of parentheses. Parentheses are right above your number keypads. X plus 2. Close your parentheses, and then you can do the exponent of 2, x squared. I'm going to push down or enter to go to y2 and put 49. And now we're going to go to zoom, middle top button once again, 6 for standard. And there it is, but I can't see where they intersect. So I go to zoom, zoom out, option number 3, push the button 3, and hit enter, otherwise it won't zoom out for you. I may not see it yet. Nope, can't see it yet. Zoom out again by hitting enter once more. There we go. Now I can see it. I can see the intersection locations. I'll go to zoom. We want to do a zoom box. Option 1. Hit enter. I'll move my cursor so I can see and make sure that I can encapsulate the crossing points. Right about there. I'll hit enter once. Push up a few times. And then I can see it go up. Go to the right. You can press and hold and it'll go up. And you can press and hold and go to the right. Now hit enter. encapsulated the crossing points. Here we go. We can now see where they cross each other. So let's find if we got the correct values. Hit trace, top right button, second from the right I should say. And we're going to enter the 5. It allows us to enter any x value, 5, and hit enter. It gives you the y value, 49, which is what we got or had plugged in as the other equation. And likewise, let's plug in -9, hit enter, and now it gives us, once again, 49, the other intersection point. So there we go. We checked it via calculation, and we checked it via our graphing as well through our calculator. Visual checks. All right, we're done with this set of problems.